Hi, hello again. Thanks for joining me for Mondays with Mike. And today it's a tropical theme because, as you've probably heard us talking about on the air, this week we got one of the forecasts for this year's hurricane season. It was the April 7th forecast. Comes out every year on April 7th, and it is the forecast from the team at Colorado State University, led by Dr. Phil Klotzbach. Now, the first thing that I want to talk about is a lot of people will ask me, why Colorado State University? It sounds random. Like they're not near any ocean. They don't get hurricanes in Colorado. You know, shouldn't they be studying blizzards or something like that? And the answer is that there are, I'm sure, atmospheric scientists there who are studying those things, snow and mountain effects on weather systems and so forth. But the reason that the hurricane season forecast comes out of Colorado State is that the pioneer of doing this sort of forecasting was Dr. William Gray. You might remember him, Dr. Bill Gray. He passed away a few years ago. But he was really in that first sort of wave of tropical forecasters where they really, took it to the next level. I mean, you think of people like Dr. Neil Frank. You remember him, right? He was the head of the National Hurricane Center, and he really came up, in the 50s and 60s, and which, by the way, he went to Florida State University. But one of his contemporaries was Bill Gray, who went to the University of Chicago, was educated there in meteorology and atmospheric science. And the reason, long story short, that we get these forecasts from Colorado State is that Dr. Gray, who was studying tropical meteorology, took a faculty position at Colorado State University, and so he continued to study his tropical weather and continue that type of seasonal forecasting, even though he was employed at Colorado State. So that's how that goes. It's kind of like, think about, you could be an expert on Egypt and you could live in Houston, that kind of thing, right? I mean, you could be an expert and authority at something. We have people on all the time, people who are maybe like experts in Middle Eastern affairs, even though they teach at Rice University, that kind of thing, even though you're on the other side of the world. So I think you get what I'm saying. So anyway, the forecast came out and showed right here, I have the numbers here for you. I have a clicker over here too, that they are expecting an above average season, a busier than normal season. So they're calling for 19 named storms, and out of those 19 storms, 9 of them becoming hurricanes, with 4 of those becoming major hurricanes. Now, compared to an average season would have 14 named storms, 7 hurricanes, and 3 major hurricanes. And so now I want to talk a little bit about what goes in to that forecast. It really is not just crystal ball. It's not guessing. It's not anything like that. These techniques have been developed here since the 70s and 80s, but really came to be known in the 2000s, the 90s and the 2000s, when Dr. Bill Gray's forecast became more popular and people became more interested in it. So what goes into it? Well, first things first, what area are we talking about? Because, there are hurricanes that occur all over the world. In parts of the Pacific Ocean, they're known as typhoons. In parts of the southern Pacific Ocean and the Indian Ocean, they're known as tropical cyclones or severe cyclones. So, but it's all the same type of weather system. The forecast that we're talking about for the 19 named storms and the 8 hurricanes and so forth is for this area that we call the Atlantic Basin. And that includes the Gulf of Mexico and the Caribbean and all the way back over to the coast of Africa. And we're talking about areas north of the equator, which incidentally, this could be a whole other discussion. South of the equator in the Atlantic Ocean, they never get hurricanes down there. The conditions are never favorable for it. So it's interesting, but our part of the Atlantic Ocean is much bigger, much wider. So anyway, this is the area we're talking about. Now we're still in April, of course, and it's very rare to see any storms in April. It's happened, but it's very, very rare. This area out here, you can see there's almost no cloud cover, in fact. As we get farther into the season, we'll notice more frequent tropical waves, which are these areas of low pressure that progress across the Atlantic Ocean, and some of those will develop into tropical systems, but none of them this early in the season. Where is the cloud cover right now? Well, it's interesting. okay? So this area here is called the, well, there's a couple of things going on. It's called the ITCZ, which not ISCOVITZ, that's my last name, but the ITCZ is the Intertropical Convergence Zone. What in the world does that mean? Okay, well, intertropical, it's in the tropics, it's by the equator. Convergence zone, well, what does that mean? Well, here you have winds that are coming in from the northeast. Those are called the trade winds. Okay, they come in like that. And they meet up with winds that are coming in like that. Also the southern hemisphere trade winds. So where this comes together, you have this zone, which is the convergence zone. And it's where you have that convergence zone that we have cloud cover and we have convection, which is why you have a rainforest here. So where you have that nearly year-round, convergence zone, which occurs near the equator, you have these really moist, kind of wet tropical climates. And it does shift farther to the north during our hurricane season, which a lot of times is the source region for where our hurricanes come from. And then it'll shift to the south during our wintertime. But this is one of the aspects that leads to like the Amazon rainforest and the rainforests here elsewhere in South America, the very wet tropical areas of Africa, the very wet tropical areas over in Southeast Asia. It's all tied in with the same kind of concept where we have this convergence zone near the tropics. So, why does this matter for hurricane season? What are we talking about here? Well, because as the season wears on, as we get closer to June, this actually shifts farther to the north. And then as we head toward August and September, as we really get, looked really short there. As we really get into the heart of what's known as the Cape Verde season, which are named for these islands here, this will move much farther north. And so it'll become, like I said, kind of a source region for what becomes hurricanes sometimes. Also, as an aside, I know some people will call these Cape Verde, which is green in Spanish, but the thing is, it's not a Spanish island, it's Portuguese. And I've looked it up many times over the years, and they actually call it Cabo Verde. Cabo Verde. So I call it Cape Verde. I'm not going to say Verde, and it isn't Verde actually. So if somebody says, well, our weather person's saying it wrong, that's what it is, Cabo Verde. Anyway, so those are those islands there. And when we get into the Cape Verde part of the hurricane season, it's generally August and September, maybe early October, but August and September is where they're sourced from over here. Earlier in the season, June, July, and then also late in the season, November, December, they tend to form closer to our part of the world, which is a concern because the closer they form to us, the more dangerous it can be because you have less time to prepare, right? Here's a closer look at what I was talking about, that intertropical convergence zone with the arrows coming in like this. These are the winds, low-level winds, coming in like that to the north of it and that to the south of it, and boom, they come together and you have that convection and rainfall. So I love that. It's pretty cool. So what went into this forecast from Colorado State and Dr. Klotzbach? Well, one of the things that he mentioned was that we have above normal water temperatures in the Atlantic Basin, which, like I said, is where we source our hurricanes. So we're talking about Gulf, Caribbean, Atlantic Ocean. And this is color coded to where we have above normal temperatures, it's yellow or orange, and where we have cooler than normal temperatures is blue. So there really is not that much blue to be found here across the Gulf, Caribbean, or Atlantic. A little bit out here in the Atlantic, just a couple of blips in the Gulf or Caribbean, but by and large, we're running warmer than normal. Warmer means more energy means a better chance for storms to form, and it also means that a better chance that the storms that form could be strong. In fact, there's an above average chance this year of a major hurricane hitting the Gulf Coast. Average year of a Cat 3, 4, 5 hitting is 30% chance. This year they're giving us about a 46% chance, anywhere from Brownsville back over to the Florida Panhandle. So that's something to think about as well. So this is one of the main factors that went into their forecast. One of the other things is taking you down here to South America. Why? What in the world would that have to do with Texas weather? Well, it does. Down here, so this is Peru, Lima, Peru. This is Ecuador. And here off of the coastline of Peru and Ecuador, especially here in Peru, you have an area where there's an oscillation, goes back and forth. And the cycle can run anywhere from 3 to 7 years it's called the ENSO, okay? El Nino Southern Oscillation. Again, what in the world does that have to do with hurricanes, right? Well, here along the equator, the equatorial regions of the Pacific, and this links all the way back over to like Indonesia, there's this back and forth shifting of air pressure, where you'll have an anomaly that's like a little bit higher pressure near South America and lower pressure over there, and then it'll switch, you know, every few years back and forth. So that actually drives water temperature as well. And so as a result, you have this switching back and forth between cooler than normal temperatures in the water, which we call a La Nina, back to neutral, which is normal, and then back over to warmer than normal conditions, which would be called an El Nino. We have cooler than normal conditions now, and that's a La Nina phase. And there are computer models that project out whether or not we're going to have a continued El Nino, La Nina, based on that pressure pattern that I mentioned to you. And the forecast right now is that most of the models are pointing at a neutral season, so that these temperatures are going to warm up a bit, get back closer to normal. And so as a result, that would not inhibit activity, okay? When we have an El Nino, it's a different story. So I have a couple of explainers that I put together here for you, okay? This is in the case of an El Nino. Okay, when we have an El Nino, you have warmer water here in the Pacific Ocean, above normal temperatures, and then you have cool temperatures, you know, always up there in Canada and to the north, and where you have the bigger contrast between the warm and cool, you have a stronger jet stream. Well, what does that matter? Well, we're talking about the winds that are blowing at 30,000 feet above the ground, 35,000 feet, you know, maybe down to 20,000 feet, but mostly we're talking about the higher part of the atmosphere. Well, the stronger that jet is, and the more often it's there, the more shear there is in the atmosphere. You've probably heard us talk about shear, high shear, low shear. When you have high shear, it rips the top off of the clouds. And so it tends to inhibit hurricanes from forming. They have a harder time forming because they try to move toward, you know, Texas, they try to move toward Florida and these places, and they encounter this, and it just kind of tears them apart. And so it keeps them from getting very strong. So this would be an El Nino pattern. That's not likely this summer. It's possible, but it's not likely this summer. It's more likely that we're going to have this, which is the La Nina, or neutral, okay? Where you're either going to have cooler waters or normal water temperatures. In that case, you have a weaker jet stream, less shear, okay? So during La Nina seasons, you actually have a greater number of storms and a greater probability of major hurricanes. It's much more dramatic during a strong El Nino. Like a strong El Nino will cut the number of storms in half. So if the average season is 14 storms, if you had a strong El Nino, it'd be like 6 or 7, and the chance of major hurricanes goes way down. Of course, it's never 0, but the total number of storms is going to go way down. In this kind of situation, given the fact that we don't have an El Nino and we have those warmer temperatures over the Atlantic, you know, that's why we have that likelihood for seeing busier than normal conditions. I do have a word up here too. I don't know if you could even see that, but you may or may not have ever heard of, but it's called a teleconnection. And it's one of the really interesting things that they use there at Colorado State for their seasonal forecasts. Is what they do is they've looked back at previous hurricane seasons, okay? And they'll look at seasons that were really busy, and they'll look at seasons that were really slow, and they'll look at not just water temperature in the Atlantic, and not just the condition of the El Nino, but they'll look at things like air pressure anomalies. Okay, is it higher pressure or lower pressure than normal over by Indonesia, Thailand? Okay, Why would they look at that? They'll look at anomalies in the jet stream. Is the jet stream flowing faster or slower in West Africa? Why would they look at that, right? Well, because they're all called teleconnections. A teleconnection is when a phenomenon in one part of the world affects weather in another part of the world. And it doesn't mean the butterfly flaps its wings in the rainforest and it causes a tornado. It's not that. It's just that everything, the whole circulation of air across the planet is driven by a lot of different things. And we can get hints about what's going to happen in one part of the world based on what we can observe in some other part of the world. And so this El Nino or La Nina is an example of a teleconnection. So warm water here, which is caused by high pressure way over here. So if you have higher pressure over by Southeast Asia, and that results in warmer water here, which gives us more shear here, which gives us fewer hurricanes here. Those are all connections. They're called teleconnections. So you could definitely impress your friends at cocktail parties now, if they still have those things. So anyway, that's kind of an in-depth look at the hurricane season forecast issued by Phil Klotzbach and his team at Colorado State University. It looks like it's going to be a busy season, but as I've mentioned many times on the air, and some of you folks that have been here for a while, this was before my time, but I was alive, but I wasn't in Texas. 1983, Hurricane Alicia. A lot of people still remember it. Category 3 hurricane, 120 mile per hour winds. It moved directly over downtown Houston. And that one occurred in a season where there were 4 total storms. Only 4 the whole season. It was the A storm, meaning that it was the first one, and it didn't happen until late August. So that year, talk about letting your guard down. No storms in June, no storms in July, no storms in August until, I think, the 22nd or 24th, when Alicia formed on a stalled out frontal boundary south of New Orleans and then made landfall less than 2 days later. So you always have to keep your guard up, and you could do that by checking out my colleague John Dawson and his hurricane gear tests. Really cool stuff. The tropical page here on fox26houston.com. And, early in the season like this, try to take advantage of sales. Try to beat the rush to the store. If you get a good deal, I'm telling you, if you can get a good deal, everything's expensive now. Anything non-perishable, whether it's Fruit Loops and Cheerios, whether it's soup or, anything that you can heat up using, if you have gas appliances, that really comes in handy. But anything that is going to be non-perishable that you and the kids and the family can eat if you lose power for a while, if you're kind of stranded for a while following the passage of a hurricane. Of course, we'll talk a lot more about that coming up. So sort of a little bit more of a science nerdy edition here of Mondays with Mike. I hope I didn't bore you too much. I want to thank you very, very much for watching. If you're watching on Facebook, please leave a comment and a like, ask a question. Here on Facebook Live, if you're watching us on Facebook. If you're catching us on YouTube, please give me the thumbs up and put a comment or a question, because I will take a look at these and try to answer some questions you have. Thanks again for watching. See you next Monday.